Good morning. Today I'm going to convert an ODB file into a step file, and we're going to discuss the problem of metal coming from component pins. We're going to start with preferences. You can see I've defined a working and an output directory, and I've set my arc resolution fairly coarse. I'm going to now import a TGZ file. I select File and Open. I don't really need the solder masks. Click Import. Some of it's been converted into Gerber, and you can see those files here. That's coming from the layer information in ODB. In the drill section, we imported the drill data. In our properties section, we've picked up the thickness of the various conductors and the spaces between them. Also imported the component information from ODB, which gives us the component placements on the top and the bottom, and also it gives us all of the nets. There's also nodes, which are like reference designators and pins. Now, for our output, we want to produce a 3DI file. We don't need the dielectric bodies for this particular exercise. We're going to select a small window, because if we try to do this entire board, it's too much for our analyzer. So we go to Window Selection, and we say Rectangular, and then we say Get Data Window. So I'm going to just cut out a small area in the middle. So I click on Define Window. Say I click here and then there. Just click OK. Click OK. So now I've basically got my setup, and I'm going to then execute this. It'll want to save my job file, and now it'll execute. So you see that it finished with 13 warnings. You'll see that there was some data on some of these layers that used a decode 21. That was set to 0. Now we're going to look at our 3DI output. When I first open this, I see this gigantic component. It looks like it's on the top side, and then on the bottom side I see a number of rotated components in that window. We really don't want to simulate these pads out here, and I want to talk about why they're there. So let's go to the layer dialog, and let's turn off all the metal layers except for the bottom one. If you look here, you're seeing metal that you wouldn't expect to see. This looks like it's distorted, but it's not really. The way we can actually identify that metal as coming from the components is that it got a flag called pin. We have everything on M10, which is our bottom layer. We have some additional attributes we can filter or color by. I'm going to change the color on the pins to something like this. And now I can see that this data here looks like it came from a footprint from the components that were placed in that angle. If I turn off the pin data, now I'm seeing what I would expect to see. Let's look at that from the bottom. So you see I'm seeing my nice square clip. Now these little round guys sticking out are due to the fact that we have a rule that we don't slice through a via. If we find that we're cutting through a via, we'll keep the entire via. You can actually see that the bottom metal and say the top metal follow the same rectangle, and if we turn off the pins on the top metal, we don't see those anymore. So now we have the area that we actually expect to see. The inner layers don't suffer from this because they have no pins on them. What we want to do before we produce step is we want to actually filter out this pad metal. And to do that, I'm going to use a function built into 3D view. I'm going to hide the component top layer, and I'm going to hide the pins on these two layers. And now I have only the layers that I actually care about. I have all my vias, and I have all my conductor layers. And then I'm going to do File, Export, and I'm going to do Visible. Only layers and object properties that are turned on will be visible. And I'm going to call this Filtered Pins. Save. Now let's open that file. We notice now that that big top component is gone, and all the pads associated with the top component are gone. And on the bottom, we have only the data we expect to see. So now we can export this to step, and we'll go to File, Export, Step for FEA.